I use Electrofrog points on my layout, and the distinguishing feature of Electrofrog points is they have this metal V here, which is all connected and conductive. Insulfrog points have a little piece of plastic right on the edge of this V, which isolates these two rails, which means Insulfrog in a lot of ways are much simpler points to use, because on your frog this rail can be consistent with the rail along the bottom, and this rail can be consistent with the rail across the top, which means no matter which position the points are in, this rail and this rail support a train traversing over it. The issue I had with Insulfrog points, the first Insulfrog points I tried on my old layout were Hornby ones, and the plastic area here was just too big. I run a few old trains on my layout. I did on my last one. I'm kind of planning with this layout to phase the old ones out and replace them with shiny new ones, but at the minute I've still got quite a few old trains that I need to support, and the plastic insulation on the Hornby points was just too big, and because old trains aren't great with pickups, they don't have many pickups on their wheels, I was getting a lot of stalling over the points. Now Pico do Insulfrog points as well, and their insulated area here, the little plastic area, is much smaller than the Hornby ones, but the problem I had with them was that with it being so small and these rails being so close together, and with the wheels on old locos being so fat, they were crossing both of these lines as they came across, which caused a short, because this one are different polarity. On my layout, the bottom rail is black, the top rail is red, so black and red were too close. Wheel was covering both and causing a short circuit. So then I moved to Electrofrog points, which have this Electrofrog entirely linked V here. In fact, the frog kind of goes back down here as well. Now, when you buy an Electrofrog point, you can put it on your layout and use it as it is. You need to put insulating rail joiners on here and here, because you've got, what's going to happen is this V is going to switch polarity based on the position of this rail, because when you switch the point here, these rails are making contact with different rails. At the top it's making contact with black, at the bottom it's making contact with red, and this entire part of the point here is linked when you first buy these points. So as soon as you move the point down to touch the black rail, all of this becomes black effectively. So that means, but because from this point onwards any rail connected to it, this is going to be red, that would cause a short circuit. So you need these two rails here isolated. So when I first got them, I tried them without modification, and there was an improvement, but the problem I had was here. I was still getting fat wheels, because if this point is now moved to connect to the black rail, this entire structure here is black, but again my fat wheels were coming across here, and this gap is too small, and they were making contact because this is red, that's black, and another short circuit. So I then modified the points again, and again this is in instructions that you get with them, you can sort of see some of it underneath, to completely isolate this part of the frog, which works and stops all the short circuits. But the problem then is this part of the point is dead. It's isolated completely from the rest of the point, and it needs to be powered. But not only does it need to be powered, it needs to be powered in a way that polarity can switch based on the position of these points. So if they're flat and connected to the black rail down here, the train wheels are going to come over here, and they're going to need this entire structure here, even the bit going down here, because it's still isolated from any further rail coming on there. They need this entire thing to be black. But if I switch the points, they need this entire thing to be red. So there has to be an additional switch that will detect the change of points here and switch the polarity on here. And on my last layout, what I ended up with was what's all piled up in this box now. First of all, I started using these Pico solenoid motors, and you can add what's called an accessory switch to the bottom of it. So this is the bar that moves the points, and there was a simple switch that you could add to the bottom, track rails in here, frog feed there, and this attached to the pole. So when the pole moved to move the points, this switch would switch the input coming into this, which went to the frog, from red to black as its switch moved, and yeah, that switched the polarity of the frog. The issue I had with these was, I think, going with instructions, they were super glued to the bottom. Some of them fell off. Also, the switch didn't always make contact, even if the point was aligned. If this bar was aligned and would move the point, sometimes this switch didn't move fully and didn't make a connection with red or black, and then didn't feed the frog wire. So 70 or 80% of the time these worked, but they were a little bit flaky, I found. The Gauge Master ones were a little bit better because they came with the switch integrated. You can see all the wires going in there, so the switch is in there somewhere, and they worked a little bit more consistently. But what I didn't really want to do, because I hate crawling around under layouts, especially in a loft, when these ones failed, when the accessory switch fell off the bottom, or when it wasn't making contact, whatever, I didn't really want to crawl under, take a perfectly aligned switch motor out from under the layout, because it was still moving the points okay. So I didn't want to move a perfectly aligned motor and then crawl back under and have to align a new one. So what I ended up with using was these, which are really quite useful. This is a Gauge Master DCC80. This might be a broken one now, because I'm not sure it should have. Oh no, that's the frog wire. That's okay. This was a really clever little piece of kit. Again, it's got the 2 track feeds, input red and black, and then it's got the green going off to the frog. What this did was it detected a short circuit, so you could allow the short circuit to happen, and on the frog, and if it detected the short circuit very quickly, it switched the polarity from black to red without actually allowing the short circuit to happen, and it basically just works. So when I was first setting up this layout, I thought this was going to be my option, because with this layout I'd switched to servo motors instead, because they're kind of more fun. So that meant these 2 options with their accessory switches and frog switching weren't options to me. So servo motors are great, but they don't come with any functionality to switch frog polarity. So my first option was to use these, because these would have worked. You just connect them to red and black, connect them to the frog, and off you go. The only reservation I had with them, although they're relatively cheap, I think they work out, I can't remember, maybe £7 or £8 per unit. But if you're talking about 40 or 50 turnouts on your layout, that's soon going to get quite expensive. So I was intrigued to find if there was another way, maybe less expensive way, of switching frog polarity while using servo motors. So I did a bit of research and I had a little look around on the internet, and I found 2 potential options for switching that frog polarity when a point motor switches the frog. First one of these tiny little micro switches, and very similarly to those accessory switches on the bottom of the Pico solenoid motors, you find a way of mounting them close to the motor so that the button gets switched and your polarity from 2 inputs and 1 output gets switched when the point moves. The second one is something like this. This is a relay, very similar to the switch, except this is an electronic switch rather than a physical one. See, there are 8 relays on this board. Each one has 3 inputs, and again it's your 2 track feeds and 1 output to the frog. And in conjunction with the Arduino, you would find a way of electronically switching between black and red when the point motor is moved. So I'm in the process of building a new layout, and I thought, seeing as I'm right at the start, I might as well try both of these approaches out for switching frog polarity. I think, going by the theory, I think I've already got a preference of the 2, but I'm going to try both out and see how they go. So approach 1 is this. This is a micro switch. And the idea behind this, very similar to the Pico Solenoid approach and the little accessory switch that's glued to the bottom. This switch has 2 inputs and 1 output. So in this case, how I'm going to use it, the 2 inputs are my 2 track feeds, red and black, and the output is the power to the frog. And it's a simple case of when the switch is open, as it is now, one of those 2 inputs is connected to the output, say black. And then when it's pressed in, it switches to the other input, so black. So if this is, I think the one closest to the V, so that's the output. The base, and this is red, this is black. So the basic approach is when it's out, then red is connected to the output, and when it's in, pressed in like this, it switches and the black is connected to the output. So what you have to do then is find a way of mounting this on your servo mount, on your layout, in a way that this will get pressed when the point is in one position and will be released when it's in another. And there are a few different mounts around that will facilitate this, and I've tried a couple. The first one I looked at was this one, and it does give an idea of how this works. This is the point motor. There would be a bit of piano wire stuck into one of these holes. Mounts on the baseboard with the baseboard above, and you can see there are 2 screw holes, and that tiny little hole is aligned with where the motor arm is, and you shove a bit of piano wire through the hole that's connected to the arm and through the tie bar of the point, and you have movement. And there's a point motor, a micro switch attached to this one in the rough trajectory of the arm. So the idea is the arm will go over and press the switch in when it's in one position and release it when it's in the other. This came from eBay. The only reservation I've got with it, and it's probably me, is this arm is so small and thin, and the micro switch is so small. There seemed to be a huge risk to me of, you can see I've ended up sticking a bit of tape to it to make one of the 2 bits fatter, but these 2 contact areas are so small. For me, there was a huge scope for missing and slipping, and obviously if every time the point moves, if these 2 aren't making contact and the switch isn't being pressed every time, then I'm going to get short circuits and stalls. So I don't fancy this one, and I moved on to one from an organisation called MERG, which just seems very well thought out and designed. So these are the point motor or servo motor mounts supplied by MERG, the Model Electric Railway Group. They're a heck of a find. They're like a club, really. You need to pay a membership fee, an annual membership fee to join, but it's not much. And for that money, you get access to all these amazing things that people have designed and contributed. Not only, and for incredibly reasonable prices, but not only do you get access to those to buy them, but you also get access to an incredible forum of people who are more than willing to explain how to use them and just share their knowledge. It's been my find of the year, certainly, in model railway world. So this is a well-designed mount, and it's 3D printed, and it comes with a few together and all the screws you need. The idea is this is where it mounts under the baseboard. It has 2 areas that you can mount micro switches to, and an arm with a big fat kind of contact area at the bottom that connects up like that and swings with the point. So the idea is it will move over there and make a big contact with 1 or 2 micro switches, depending on your configuration. I'll probably end up using 2, but the second one's nothing to do with point motors, so I'm not going to go into that. So this is the mount that I'm going to use, and I'm going to get on with getting them mounted under the baseboard and testing this micro switch approach out. One thing to note, I was a bit heavy-handed when this arrived. Never really worked with anything that's 3D printed before. You can see it kind of comes in all connected, and you have to break everything out. Now, I sort of went in there like it was manufactured plastic and tried to snap everything off, and in doing that I snapped this arm. You can see there's a hole in it there, and this is the area that the servo arm sits in. So by snapping that, it means the servo arm won't stay in there, and effectively broken this point. So when working with these, when you need to break everything out, use scissors, snips, whatever, and very carefully break each of the components out of their casting. Otherwise, if you approach it like a heavy-handed buffoon like I did, you'll end up snapping them. I think I got my first 4 sets of points in. I think this is all ready now for point motors and wiring up. So each set of points has had its spring removed, so it's loose. Got a dropper wire across the 2 rails there and across the 2 rails there. Frog wire is through the baseboard, and there's a big, I don't know if you can see the light through it, there's a big hole drilled underneath each bar for the motor. So now it's time to start getting point motors fixed underneath. I think I'm going to go with the MERG ones, at least to start with. These ones, they just feel a little bit more kind of central to the points and secure. I'm going with 2 Microswitches. I think I'll probably only need 1, but they're less than £1 each, so they might as well be on there. Actually, before I fit this one, I will solder some connecting wires onto those switches so that I don't end up soldering underneath the baseboard. But what I'm going to do, what I didn't do with the last layout, actually, I can't believe I didn't cotton onto this, the motor is going to go underneath like that and stick up through the tie bar. Now with the solenoids, every single set of points I did on the last layout, I got underneath, tried to align it, then drilled pilot holes, and then drilled the thing in, and 5 times out of 10 it wasn't aligned. So this time what I'm going to do is, because I know it's going to be kind of under there, I can't really do this on the camera because I haven't got enough hands, and I think my daughter's nicked my tripod. I can't find it now. Turn it upside down like that, then put it through the tie bar this way and make sure it's at 90 degrees, and then mark through the drill holes onto the baseboard, pull it up, drill through those pilot holes from the top, and then those markers as pilot holes from the top, and then it should just be a case when I go underneath of putting it up through the tie bar and drilling it, screwing it into the pilot holes that are already there. This point motor, despite looking a bit wonky underneath, is now lined up and aligned. The pilot holes thing really did work, but in the end I needed, if I just scroll back, I had to screw a backrest to that set of joists, just because I just couldn't. It's so far back, it's right at the back of the layout, couldn't get underneath it. So I put myself a backboard against the joist so I could lean with my back against that and my head underneath, and that made life a lot easier. It is really hard to see just because of where it is, but there's a little view of the front of it. There are 2 Microswitches, the other one I'll talk about later. The one that's being used at the minute is the one on the left hand side. You can see the red and black cables coming out of, and you can just see the bottom of the arm there and how it moves against either of the 2 Microswitches as it switches the turnout blade up there above the baseboard. So I've now got the 2 power cables connected up via that block, and that goes off to the track power over there somewhere. I like doing it this way because the logic involved in whether if I get it the right way around, effectively when the button is pressed The red, it should be the red rail. When the button's not pressed, should it be the black rail? I think I've got it right. I think I worked the logic out, but I could well have got it wrong. And obviously if I've got it wrong, every time a train hits that frog, I'm going to get a short. So what I'm going to do is, if I have got it wrong, I'm just going to switch 2 of the wires in that chop block around, because that'll mean I've still got all the right colours going into there, and it means I don't have to pull the machine, the mount back down to switch the soldered wires, and I'm certainly not going to try soldering them all the way under there. So alright, I'm going to start the layout up and see if I got it right. So here we have a Ginty. Track power's on. Most of this little stretch of track is powered up, but possibly only one set of points has power to the frog, so there isn't really much room to run. So the idea here is those points are closed. The frog is connected to the microswitch underneath the baseboard. The microswitch is connected to the track power, red and black, and based on the position of the frog, the microswitch will either be pressed or not pressed, which will switch the polarity of the frog. And if I've got all of that logic right, this Ginty should continue once it hits the frog, and we shouldn't get a short circuit. And we've got dirty track as well, so I'll give it a little push. There it goes. Slow down a bit. I think it actually just stopped a bit too soon, so let's give that another go. Oh, and we got a short circuit. The power is off, so I'm going to switch those 2 wires. Now what I've realised when I've come to swap the wires over is I might not actually have cabled it up incorrectly. What's happened, and I can't really get round either to film it or to fix it, and it's very much a beginner error, so I thought I'd include it and explain it. When I was putting the mount together, it's 3D printed, it comes in a little kit, doesn't take very long to put together. I moved the micro switches as far away from the arm as I could, just to give myself space to work, and the idea was that once it was under the layout I would adjust them and move them to where they need to be, because once it's mounted on the layout, I know how far the arm's going to move the points. But the problem, of course, is I've mounted it right by this bar, and I can't get a screwdriver in there to switch them. I don't think I can anyway. I certainly don't currently have one that's short enough. So I'm not actually going to be able to adjust those micro switches to move them closer to the arm so that they actually get pressed when it moves. So I did manage to crawl under in the end and move those micro switches slightly, so I do think they're now making contact with the lower arm of the mount. So I'm hoping now that with those in place, all 4 combinations of these points will now work purely on micro switches, and yeah, there's still no relays involved, so we're just using the micro switches underneath the baseboard, and the track's still dirty, so it may still stall. So this one is straight over. And that's looking good. So I'm now going to switch the points so they're facing each other, and it should now go all the way over onto the incline line in reverse. Let's hope it starts. Excellent. So now all we need to do, go back to turnouts, straighten them both up, and it should now go straight on. It's not going to go very far straight on because the track immediately after the points going up the incline isn't connected to anything, so as soon as it passes that insulating joiner it'll die anyway. Yeah, it's died, but I've still got track power, so both of those points are working with the micro switches. And as this starts to take life down here now, I have a wired up relay. So basically it will take the 2 red and black wires that are hanging down there, will feed into the bus wire, and then they simply wire every single one of these modules in the same way. So the left hand one is red, middle one is green for the frog, and the black one is the black rail, and then they loop on and continue. So red, green, black, red, green, black, red, green, black, all the way along to the end. And they're simple switches, just like a lot of frog polarity switches, I guess. They take an instruction on one of these pins. I think there are probably 10 pins there. There's one for ground and one for 5-volt power, and the rest are all instruction pins, one for each of these relays. I've kind of butchered the servo control board a bit up at the top, in that those servo control boards really are meant to have all those sets of pins across the middle, the yellow, red and brown or black, whichever colour they are ones. It's meant to control 16 servos, but what I've done is I've commandeered the second half of it. So the first 8 connections, numbered connections 1 to 8, are for servo motors. The second 8 are for their corresponding relay pins. So what that means effectively is the pin number 1 that's connected to turnout number 1 has a corresponding pin number 8, which is connected to relay number 1. And so all I've had to do really, I did a quick Google, and it turns out that these boards, although the control, the Adafruit library, has these gradual scales of control because it's PWM, there is also a command you can use to switch it fully on or fully off, which is what I need for a relay, because it doesn't have a sliding scale, it's either on or off. So all I needed to do in the end was modify the sketch that's running on the Arduino that controls these motors to just say, when you throw a motor by its ID being the pin number, then also switch pin ID +8 to fully on or fully off, whichever one it is, I can't remember. So it's just one line. When you throw a point, also add 8 to your ID, and then throw fully on or fully off, which will switch the relay. And you can sort of see I've got out my phone here, so you can see if I can get them both in the screen, which isn't easy. Let's try going around this way. You can see when I throw a turnout, you can hear the motor go up on the little bit of layout that I've got, but you see those lights come on the relay as well. So both, and you hear the click as well, actually. So you can see the action of throwing a turnout is not only instructing the motor to move and turn the point, but it's also telling the relay to switch the polarity of the frog. None of those are connected yet, the frog wires or the layout wires. So that's my next job, to connect those frog wires in place of the old Microswitch ones and see if they do the job too. So I now have the second 2 point motors, servo motors, attached to the baseboard. You can see, learning from previous errors, I've got this one mounted with lots of space in front of the screws on the micro switches, so that if I do need to adjust them, and I will need to adjust them because they're not aligned yet, there's plenty of space for me to do it. I've carried on wiring a micro switch for the first method of polarity switching, just because it's easy. They're less than £1 each. I might as well stick a few wires on it, and I'll have that option in case something goes wrong with the relay approach later. So if I get to a point where the relay approach is proven, I might stop attaching those switches, but for the time being, just for a bit of contingency, they're staying on. I mentioned earlier that I had to add a line or two of code to the Arduino script that I'm using to control the servo motors. It's probably worth mentioning at this point that my inspiration or motivation, certainly in starting this new layout, was to use the Arduinos and to see what they could do, and to play with them and play with the code, because I'm a geek, I'm a developer by trade, so this is kind of my thing. I wouldn't have done it if I hadn't seen some great videos on YouTube about it. I think starting the earliest one I saw was Newcastle Central, feeling Ian's pain as he wrestled with shift registers and signal LEDs, and not because of the pain he was going through. I just thoroughly enjoyed that video. I thought it was fascinating, and obviously it had a happy outcome. Motorhomer as well. I've seen a lot of his videos. You know, he's gone back a few years now. He was one of the pioneers, I think, doing great things, and more lately, Little Wicket. There've been some really quite, from a techie point of view, I guess, inspiring videos. And most of the code I'm using, I've lifted from them. There's no point reinventing the wheel. I think there's bits of code by all of them that I've kind of butchered, copied, pasted, and stuck together. There's a very useful calibration script around, which I've modified slightly because late last night, about 1 o'clock in the morning, I was trying to calibrate a set of points, and basically you enter a value of microseconds that you want the thing to move, and there is a big warning on the script here, but absent-mindedly I think I put 100,000 in instead of 1,000 and fried a servo. I was lucky, actually. It went absolutely hot and unresponsive, but I left it overnight and it's fine again this morning. I was thinking I was going to have to dismount and replace it and mount the thing again, but it's okay this morning. So I've put a little bit of code in. I added a bit of code to this calibration tool just to prevent ridiculous values being entered, not just at 1 a.m. but at any time of day. So if it gets something that's really out of range of what a point motor would use, it just doesn't apply it, so that I can't absent-mindedly fry any more servo motors. And also just added a couple of lines so that I can dynamically change which servo I'm calibrating, because I'll end up with 8 attached to this one. I don't want to have to modify the code, upload it to the Arduino every time. So I've just added a couple of lines that allow me to dynamically switch between different servos on the board while I'm calibrating them. What I've also had to do is add a new array, because I did start testing again all the 1 a.m. stuff late last night. I got the relays connected up, and exactly the same as I do with the microswitches, I'd got them cross-wired and needed to switch the way I was doing it. I was going to do it in software, but realised it wasn't just a case of adding one line, because I needed to be able to have a setting that said an array effectively of my relays, and a true or false setting to say this one needs to be inverted or this one doesn't. So when the point motor gets thrown, it checks the setting for the relay for that particular, the relay related to that particular servo motor, and determines whether it needs to either switch polarity the regular way or switch polarity the inverted way, which took a few more lines, but not too long. I don't know if you can hear a little rattling noise if I just stay quiet for a second, if the camera picks it up or the microphone picks it up. That noise, I think, from testing and trying to understand it, is the servo motor underneath the baseboard trying to move further than it's physically able to do. So when you set a servo up, you give it kind of boundaries, you give it values in the Arduino script that tell it how far left and how far right it needs to move when it's told to move the points. And it's obviously possible to ask it to move further than it's physically able to, because there's a hole there and the points will only go so far. I think that rattling noise is it trying to move a little bit further than it's able to, so I need to go back into the Arduino script and just reduce the value slightly of its thrown position, and then it should stop making that rattling noise while still moving the point as far as it needs to. So here we are back on my tiny little bit of layout. We're now set up so that those far two set of points over there they have a servo motor mounted underneath, and they are connected to the relay. The first two are still connected using microswitches. The Frog is connected using the microswitch approach. The software is configured, however, to throw the relay when those two switch. So you will hear a relay click, but they are the Frog itself is still connected to the microswitch, whereas those two are connected to the relay. I'm going to try and get my phone in as well, just to demonstrate, because I really like this engine driver app. It's really quite nifty. So I'm going to first of all go to points. Now, these to say whether they're thrown or closed, they might be the wrong way around. I haven't even looked at that kind of level of detail yet in JMRI. That's not what I'm doing, but they're easy to invert if they need to. Also, once I've got panels and things, they'll be paired up. 1 and 2 will be paired up so they move at the same time. The same with the other two, but that's much further down the line. I don't need that kind of detail yet. So I'm going to press a couple of buttons. That's good, and the camera may or may not be able to pick them up. But you can, if I shut up for a minute, you can hear the relay moving as well when I throw them. Or when I drop my phone. Okay, so there's our little train. That's still the rubbish Lima Ginty, so it may well stall, and the track's probably still a bit dirty, so there might be a bit of pushing trains involved. But I'm going to line those points up so that they are straight. I think number 1 is straight, number 4 needs straightening up. So this time the Ginty should just run straight along the track, straight across both points. So let's see what happens. We got a stall. Looking good. Just got to the stop button in time. So now let's go up and down. So cross both points and come back to the same place. So back to turnouts, and I want to throw number 4, and I want to throw number 3. 2's in the right place. 1 needs throwing. I'm just going to stand up, make sure that's right. Yeah, that looks good. So we should be crossing the lines this time. Put him in forward. Stalled again, I need to go for a walk. Success. So I guess that's my little adventure with Frog polarity over. I think both approaches have worked really well. I've enjoyed connecting them all up and testing them all out. I think the micro switches, I still have reservations because of the physical connection required between the switch and the arm. I think although they are screwed in well, I haven't actually aligned those ones, but they do screw in quite tightly. They might move over time. I don't want to be crawling around under the baseboard if something goes wrong, but they're cheap. A micro switch is less than £1, and possibly the number of mounts available that are actually well thought out and designed is possibly down to 1, which might be a bit of a reservation. But yeah, they're cheap, and they're incredibly simple, and they work. So if they were the only option, if relays weren't an option there as well, I'd be more than happy to wire the layout based on them, and just keep checking their alignment every now and again. And then we come to the relay, which I think is definitely my preferred option of the two. I have to say it is a preference, it's a personal preference. I don't think one is particularly better than the other. They both work really well. I prefer the electrical method of just adding a few lines of code, setting the Arduino off and letting it cope with it, to that slight dependence on physical contact between two moving objects. But I could, I totally understand if the micro switch approach doesn't involve any code or anything like that. So it's very accessible approach. It's probably worth me saying I deliberately tried not to make this any kind of a tutorial or how-to video. I think there are plenty of good ones around about setting up servos and Arduinos, that kind of thing. I think sometimes it's just interesting to see what's possible and what can be done, and then the actual how-to is straightforward after that. But I'd be happy to add any information if anyone asked for it, or provide the bits of, the lines of code that I've added. The way I've approached it, it does cost half of the servo board to control the relay. Again, that was a preference. There are other ways to do it, but I like the convenience of the 5-volt supply. And also these things are relatively cheap, and they can be chained together as well without costing pins on the Arduino, so it's not a major thing for me. I also, kind of a pleasant surprise really, that the relay retains its configuration after loss of power. Again, I've got a power switch here, so I'll just switch off the 5-volt supply. You can hear the click and everything gets switched off. The lights stay on because the Arduino is providing some power, but then if I switch it back on again, those two lights come straight back on, and we're away. Surprisingly, I thought this approach would be more costly than the Microswitch approach, but it actually isn't. These things are, really quite inexpensive. I think if you take into account the cost of half of a servo board and then a full relay board, amazingly it still works out at about 75p per set of points, which is roughly the same as the Microswitch. So if you had 25p for the cabling and stuff, you're still talking about a pound per set of points, taking into account, of course, that you've already bought the Arduino and all the other stuff because you needed them for the servo motors anyway. So just for adding Electrofrog control to it, it's about £1 per set of points. Which is roughly the same as the cost of the Microswitch. So I've got a lot more points to add on. I need to move on now as well to, I've kind of done the Arduino connection lazily. You can see the USB connection there. I need to switch that to using RS485 so I can chain a few of these Arduinos together. But I'm happy now with the point motors and the Frog polarity control, so attention shifts to more electronics, I guess.